Okay. So, make sure that's working. Good. All right. So, we are here to talk about accessibility, reproducibility, and reusability, and how we can bring them all together, and why we would do that. And then the next sort of meta level, how do we then teach students those things? So, um, before I go any further, I want to draw your attention to the fact that I am officially releasing this slide deck under a CC BY share alike license, which just means you can do pretty much whatever you want as long as you attribute me and as long as you release whatever you do with it under the same license. And there's a link there if you want to know what that means. This is an example of a best practice for fair data and fair things, and we'll be hearing more about that later. So I'm also trying my best to do this as a universal design for learning aligned presentation. So physical things, I'll be doing various things that aren't physical as well, but physical things I've done with the presentation, it's kind of Spartan, and that's because I want it to be responsive to flipping the screen, inverting colors, I mean, things like not having text that's too small, and all those delightful things that you can see here. This is all pulled from various places that you can find best practice of your PowerPoints, if that's something that you need, although I suspect that a lot of people in this audience are already pretty far down that road. Uh, Carlos did a great intro for me, so I won't belabor this too long, but a couple of things I would like people to know about me are that I use he, him pronouns. My name is Andrew Hasley. You can also call me Drew. Uh, I answer to all that. I've got contact information down there at the very bottom if you want to find me. And also, I am a blind scientist. I will tell you right now that a lot of times, even especially professionally, when I go give presentations, I don't bother mentioning it. And there are various reasons for that, and that's a whole other presentation on disclosure. But for here, and to get a little bit of, frankly, credibility, it's relevant to this audience, especially for those who don't know me. If you need a little proof, I've got me next to my guide dog there on the right. That's our graduation photo. Um, that's my 80-pound yellow lab. Oh, are people having issues with my slide link? Okay. Um, Damn. I will have to try to fix that after the presentation because I don't want to take up people's time trying to fix it now. I thought I had it figured out, that anybody could view.
Drew, I can help. I can maybe, is it okay with you if I make it a Google document
Yeah.
and then share a link? Okay, I'll do that.
Yes. Although, fair warning, as a Google slide presentation, it should do just fine. But that can break the reading order. So just know that you'll have to fix it if you want to, because it might read objects in funny orders for screen readers and stuff. All right. Second piece of who I am, Carlos gave you some of this, but I think it's important to establish a background for this and why I think about UDL and FAIR a lot. And it's because I've worked a lot in both worlds. And what I do right now that isn't on this slide, but it was on the previous one, is I am a federal contractor. I work for a small company called Covalent Solutions. And I help the Office of Data Science Strategy at NIH do things in the space of helping build capacity for researchers, both inside and outside NIH, to share their data, to make that data reusable, and to make it um, kind of not be a one and done thing, and make that more of a culture of data sharing and data sharing in ways that work. And one of my pet interests that comes from back in my days at BioQuest and NC State is that I actually think there's a cool interaction that can be explored between things like the fair data principles, which I'll talk about more, and universal design for learning, which we'll also chat about a little bit, that are actually intersecting and have some common best practices between them that can really help us prepare our students to do some really cool stuff with data and data representation. I do need to throw this up. I do not represent Covalent Solutions. I do not represent the government. Please don't ask me to go to your program officer, and I also promise not to tell your program officer anything. I am here as me, literally on my own time. I've worked on this whole presentation on my own time. And I also bring that up not just to completely absolve myself of anything legally, but also because I think it's worth pointing out that I don't have a position right now that lets me really work on this a lot more than thinking about it. I don't have students to do research alongside. I don't have a class to try some things with. I don't have a lot of those things in my current position. So if you think this is cool, let's talk, because it's not probably going to get a lot of traction and get worked on unless somebody who is fortunate enough to have a position in the academy can do it. I haven't had the right success at the right times in my career to have an academic position at this point. But that could change later. Who knows? So I'm going to put the bottom line of this up front so that my thesis sort of, if you will, doesn't get lost in the rest of the presentation. My argument that I'm going to try to make is that there's a set best practices at the intersection between fair data principles and universal design for learning that can serve the goals of both those frameworks that are trying to do good things, and I think we should teach them. So this comes from the idea, for me, that there are two challenges in STEM. And well, there's many challenges. I'm sorry, I didn't mean to make that a tautological statement. Two of the challenges that I'm trying to address here: how do we make data accessible to the broadest possible diversity of students, users, reusers, other researchers, right? We have this glut of data that we're trying to figure out how to actually make it all interoperate and work together and be useful to do something. We're trying to figure out how to represent it. And I'm not saying visualize it on purpose, and we'll get to that later. We're struggling with how to even learn what we can from all that data, know the unknowns about that data and all that. So how do we do that in ways that are consumable? Then there's also this, how do we make it as reusable as possible? Not just consumable, not just understandable, but make it so that I can take it and combine it with someone else's, so that I can look at it from a new angle that wasn't even something you considered when you collected it. And do that in an ethical way that doesn't misuse your data. There's all those kind of challenges too. So let's talk about challenge one: accessible data. I need to make a comment about the word accessible and accessibility. In this talk, it will be very easy to conflate two different definitions because I'm going to be talking about two different ones. There's broad sense accessibility. That's the things that you tend to think of. Can I get in the building? Can I open the door? Can I use a screen reader on that web page? Is this graph accessible to assistive technology? Have I made multiple versions of thing X? That kind of accessibility. There's also a more narrow and unique kind of accessibility within the fair data principles, which I'll dig into more later, but I wanted to bring it up now for the sake of words matter, where accessibility talks explicitly about literally being able to access data. Is there a defined protocol for doing it, like FTTPS or HTTPS? Or, and then is there for, if it's restricted in some way, okay, is there an authentication authorization procedure that can be handled electronically? Can a machine access the data? But that is linked to the broader accessibility question, because if a machine can access it, so can my screen reader. Maybe. We hope, right? So that's a taste of what we're talking about. But I needed to put this out here because I'm going to be talking mostly about broad accessibility, but there's going to be a point where I need to talk about it more narrowly. So, how do we deal with the challenge of making data accessible? First, I need to have everyone work on shifting out of an accommodation mindset. Not that it's not useful. It's very useful and it does matter sometimes. There are times where I'll need something, like in that example, that's fingers on a Braille page. There are times when I need Braille. Braille isn't going to help anybody but a Braille reader. Usually that's a blind person. Not always. Happy to talk about that more later if anybody's interested. But so accommodation is always going to be there. But when we're talking about data, we don't want to be doing unique things for one individual or two or three individuals. That's if we have to, we can. We should be prepared. But wouldn't it be better if we can minimize how often we need to do that? And that's where we start thinking more about a universal design approach to making data accessible. Picture of a laptop there, because give me many paths to understand that data, that scientific data that you're trying to show me or that I just generated, right? So before I launch too far into this, I'm going to ask for a quick interaction here. And this is one time where I will pause to actually listen to the things coming into the chat. If you could all do me a quick favor and rate your familiarity with universal design for learning as a framework based on this sort of scale I've thrown in here, where 0 is haven't ever heard of it at all. 3 is, oh yeah, I do that stuff all the time. It's basically how I teach. I love the 3. Can you please give the rest of my talk? Just kidding. Uh, all right. I won't spend a huge amount of time then. This is helpful to me, and I appreciate everybody who's put one in. So let's, we mostly as a group understand this concept then of necessary for some, beneficial to all. And I think that works for data representation as well. So these are the UDL guidelines from CAST. If you have the slides open, this is linked. You can poke it and go to their website to see a more readable version. To keep things quick and short, I'm just going to say that where I think the most intersection is going to be, and most of where I'm focused here, is in the top row of these 3 components, right? Designing multiple means of engagement, representation, and expression. Not going to talk too much about engagement, simply because I think there are pieces that are part of this intersection that I'm going to make a case for, but for the most part, engagement is around why someone should care about your data, why your data has value, why it was interesting, why you collected it the way you collected it, some of that. That is interesting, but not my focus here today. So it's mostly about representation and expression. And it's mostly in that top row, providing multiple ways to get at it. Practices that by definition will make it easier, will provide multiple ways to interact with the data, to play with the representation, to represent the data in different ways, and also different ways that that data can actually be displayed to others, allowing me to reuse it and put it out in different ways, and things that the person who originally produced that data, who originally shared that data, can help me as a secondary user of that data also have multiple ways of sharing that data. Okay. And I will be happy to answer questions about this when we get to bringing it all together. Okay. So our second challenge is data reusability. There's a big push across disciplines right now. I know I work in the biomedical space at the moment, although Carlos knows this. I'm a secret ecologist at heart and not really so secret. And so a lot of disciplines have gotten to the point where they want data sets to be able to be combined. They want them to be able to be reused. They want them to be reused appropriately. And what needs to happen to facilitate that and make it easier? And part of the reason to do this is one, because it gives the most benefit to the original work that went into collecting that data. And in the case of data that might have involved human participants or something like that, the generosity and good faith of those participants that that data would do something good, right? So we want to do that. And one of the ways to do it, sorry, is using practices that align with the fair data principles. So this one, another one where I'm going to ask you to throw in the chat on this scale from 0, never heard of them, to 3 of, oh yeah, I teach about fair data. I try to align my research data with fair, and then 3 somewhere in the middle. Go ahead and throw me what you've got. Okay. So this is good. This is fine. We've got some 0s and 1s, 2 or so floating around. All right. Thank you so much for giving me that level set. This is a question where I never know what I'm going to get. I could be in a room of data scientists and get 0, or I could get all 3s. And so here's what we're dealing with. And again, this is another one that there is, and in fact, if somebody's feeling very nice, they could throw this link in the chat for me too. But it's linked in the slide if you've got them down, and it takes you to a page from the Go Fair Foundation, which is a group over. Thank you so much, Catherine. It's a group over in Europe that kind of has taken stewardship of the fair data principles. There was a paper that came out, and I should have put the DOI in here. That's on me. I will try to share it later. There's a paper that came out like 2015 that was the result of a bunch of international working groups with the Research Data Alliance and some of these bigger international working groups coming up with a set of very aspirational, not checklist, but aspirational principles for what is good scientific data. So the concept is this. It's making data, it's these 4 principles: findable, accessible, interoperable, reusable. So making data findable means things like, does it have a persistent identifier? That data set, does it have a persistent identifier? Sometimes it might even be a data object like a sequence or something. If it goes in GenBank, it's getting a persistent identifier. If it's a set of data that you put into, say, Dryad, Figshare, Zenodo, or maybe a discipline-specific repository for like cancer data or something like that, it's probably going to get a DOI or some other persistent identifier minted for it. And that makes sure that it lives somewhere permanently, that there's always a permanent pointer, even if the data has to go away. And that's a whole interesting discussion. The pointer exists for forever. It also means having good metadata, right? Because a search engine, we'd like it to be able to index it. We'd like it to be able to find your data. And so you give it you make sure that it's done with rich metadata. And there's a whole list. There's 15 total across these 4. And I'm not going to sit here and try to ask you all of them, but I would like you to have that page open for something we're going to do later. So findability. Can someone know that the data exists? Okay. And then there's accessibility. And I already talked about that one a little bit. Accessibility, and it's good that it's this icon with a hand clicking a button, because that's really what it means. Is there an interface that a machine and a human can use to access the data? If it's open data, it's just, is it stored somewhere that I can get it with a normal protocol that my computer and the internet know how to use? It's not buried on someone's hard drive in a drawer in their lab. Um, the and then there's stuff with controlled access and things like that. We can talk about it if people are interested. Interoperability is almost exactly what it sounds like. It's, can my data interact with other data? So that means it's got to be in similar formats. We need a mapping between the variables that were used in dataset A and dataset B. Maybe they should use a common schema for that. Do the metadata line up such that those data can talk to each other and possibly be combined or linked? And other types of data from other disciplines generated by other software. Are those data usable together? And then there's reuse. And reuse is the cool one in a way for me, because reuse has social components. Reuse talks about, are you using community standards when you share your data and when you collect your data and when you generate your data? Are are you using really rich descriptors for your data? So not only does it have metadata, but are those metadata good? Are those metadata relevant to other people in your discipline or people in other disciplines? Did you release that data under a license so people know what they're allowed to do with it? Because you could put all the data in the world out there, but if it's not released under a license, technically no one can use it for anything because copyright is self-executing. You have to explicitly release it. So the reuse captures all of those things, and it's where really the community stuff gets involved. Community's involved in interoperability too, in terms of coming up with standards and protocols and what we accept and what we don't, things like that. But a lot of the action happens in reuse. And the whole point of this is to make sure that not only are data, when data are shared, sharing is great, but if you share something that can't be found, what a waste. If you share something that can't be accessed by anybody ever, we all know it's there. It's got a DOI, but it's locked down tight. And, you know, what we're trying to get past with this set of principles is data are available on request. Studies from Metascience have gone out, and I should wish I had one to share with you all, that basically can show that about 80% of the time, data available on request is a lie. Either they can't be moved around easily because of the system they live on, or the author just never emails people back, or whatever. Like, people have done the homework on this. It doesn't work. We need better. And FAIR is the attempt to codify a set of principles that make it better. Okay. So, Drew, the hell do those have to do with each other? What does any of this have to do with teaching? Fair question. So I've shown you a framework that people can lean on to make data accessible. And there are practices within UDL that can help make data accessible. I'm not necessarily just talking about the technical side, although I'll show you a toy example here in just a second, but more broadly than that, making data that our students can use and showing them how to make data that their colleagues someday can use. We have a framework for that. We also have a set of principles for maximizing usefulness. They're principles. They aren't a good checklist. They're not even a list of best practices. They're a set of, this is what it would be cool if your data was, and the metadata that are associated with those data. And by metadata, for anyone for whom it's not clear, I realized I should be careful. Metadata is data about data. So the metadata for, let's say I have a data set where I went out and I did my favorite thing and I went birding auditorily and I did point counts and just cataloged everything I could hear and knew what it was. And I go to share that on eBird, which is an app where community shares what they're seeing and where, and it's used for occupancy stuff and cool things. The metadata for that data on the birds I saw is, who's the author of that data? It's me. Who collected it? Me. What tool did I use? BirdNet. What date did I collect it on? All those things are metadata, and they are really critical to making data useful. If I don't know what your variables mean, we're in trouble. I can't really reuse your data. And, and by the same token, if your data is in a very obscure software format that only two computers in the world can read, not super useful. Maybe useful to those two people and you, but that's about it. So we've got frameworks for both of these. What do they say about what we should be trying to teach students that will make, if as long as they go on in science, or just so that they are literate when they see data elsewhere, help them make data that they work with both accessible and useful to the scientific community, and ideally beyond the scientific community. So hopefully a little bit of a toy example will help with what I'm talking about here. And this is where it might help, again, if you've got a local copy open, you're going to want to flip between this slide and the next one. And I don't have the thing I'd usually do with this, I have to make sure everybody has a local copy. But if somebody's got these two open, go ahead and unmute yourself. How are they different? The two charts. And it's okay if you can't find it because it's interesting. So the reason that these are different, one is a screenshot. Yep, it's a ping. What is the other one? Can you flesh that out a little bit? You don't have to know exactly the name of it. Just how did I get it there? Yes. Carlos hit one for me. The second one was built in Excel and pasted from an Excel sheet. Now, that itself isn't what makes it interesting. What makes it interesting is what Microsoft has made possible with that. You can do things to that image, to that, not image, to that object. And you can't do it in slide view, and I found that out in the presenter view, and I found that out like 5 minutes before this, and it made me sad. So I apologize. But if you actually right click, or your equivalent of right click on that object in the second of the two slides, you can edit the data. You can see a table of the data if you do that. You can learn what the axes are. And what's really cool is that one I can move around with a screen reader. I can hear what the series is called. I can hear the value of each category bar. I can do all of that. I can't do a damn thing with the image on the first slide. Somebody enterprising might suggest that I could throw that first image at generative AI and ask it to tell me about that chart. And you're not wrong. And it works 90%-ish. It will sometimes, and I've tried with a couple models of ChatGPT, I've tried with Gemini, I've tried with a few others. And sometimes they get it absolutely right and can tell me what every bar was in the graph and generate a very nice text description. Other times, not so much, or they'll miss a bar, or they'll try to tell me more than I need to know. Some of it is prompt engineering, but usually the upshot of this is that usually I need to craft a carefully crafted prompt and try 2 or 3 times to get the actual information I want. So we're getting there. That's coming. That will help. But at the end of the day, usually images are bad. So I've made, by using something that Microsoft happens to offer, I've made that image more accessible to a screen reader. If I can embed it anywhere I can embed it that keeps all of that information, that metadata that's behind it, it is a more accessible version of the chart than the image. It's also, in theory, more fair. Fair is a continuum, not a binary. There are things about the figure that wouldn't be fair. It doesn't have a persistent identifier assigned yet, right? Um, but it does have rich metadata behind it. They are in a format that anybody with a Microsoft Office capable reading thing, so anybody with a browser, can open. It'd be nice if it was an open file format, but can't have everything. We're on a continuum. So it's more interoperable. And because you can grab the data out of it and put it into a table of your own, let's say you have some updated statistics, and then you want to put multiple years on a chart, you can do that with this one if I give it to you. With the image, you're stuck. At best, you're going to have to pull it out by eye and by hand, and that's cumbersome and not very fair. But if you're using the meta file, it's fair. It's more fair. This is an example of the kind of things I'm talking about. So the best practice here, and the best practice I would teach someone is, as long as people have access to something that can open a Microsoft file and you built it in Excel, don't paste images, right? That's the best practice. So there's a thing about accessibility. There's a thing about reusability of that data. They come together. There's a best practice that comes together and accomplishes two things at the same time. Those are the things that make me excited right now. It's the kind of stuff I'm looking for. And if we do it, we end up fixing this graph, because I assume that some of you have actually looked at the content of the graph, and it's depressing. This graph is showing basically the percentage of people identifying as having a disability. So already it's a low estimate because identification is a whole ball of wax on its own at various career stages. So we start out at 13%. That is a low thing. The average estimate in across the world is 1 in 4. Fine. And just as we keep going through the pipeline, we drop to the point where we're down to 2% getting doctorates. I am way too rare, and I am not that smart or that especially hardworking or anything else. It's just I had some opportunities and got lucky in some ways that other people didn't, and I work hard, right? This is fixable, and I think given that data is becoming the currency of science, this thing that I'm thinking about and talking to you about has some tread on it to try and make things better. So what I want to do, I would like all of you, and we have time for this. It looks like I've done okay with my plan. Take about 3 minutes to sit and record in whatever way you like. Open a recorder, draw on pen and paper, type it into something. Like I said, universal design. However you want, record some best practices that you can think of. Probably in most of your cases, things you already do in your instruction that might address both of these, or things that looking at both of these frameworks and thinking about them together makes you think about that would be cool to do. Don't worry about how you'd actually do it yet. Just think about uh, some best practices that this triggers in your head. And some of them can be really simple and some of them can be really complicated. I'm going to show you some of my own later. And if you skip ahead, you can cheat. But I want us to do this way first. So first, do it on your own. And I'll give you your, let's call it 2.5 because I rattled. And don't worry, I'm not going to ask you to share with everybody, at least not right away. Okay. So we've done that piece. And hopefully it's okay if you're staring at a blank sheet of paper or a blank screen right now. That's totally fine. Um, but hopefully most people have some. And this is where I'll ask for the moderator's help in just a second. It'd be nice if we could throw together some breakout rooms. I would have liked 10 minutes, but we'll call this 7 because I want time to talk about it. And 3 to 4 groups of 3 to 4, I think would be optimal for this, just so that folks actually have time. And if we can't do that, we can do this as a big group, but we've got enough people that I think it's worth it. So what I want to do is have each person share, 1 if they've got it, 2 if they do, of the best practices that they think align with both and that are interesting and worth doing. And then now is when it would be good to talk together and think about strategy. Like, how could we actually, what are some ways we might actually be able to teach that best practice? Um, and kind of go from there. Um, and then just be prepared to have at least one person from the group share something interesting that came up or a particularly unique practice or just where you got confused, where you hit a challenge with how we could do it. That would be really helpful. And then we'll kind of come back and talk about it, and I'll wrap up with some of the ones that I see. Does that work? All right, my lovely moderator people, if you're able to do that for me, it'd be awesome. And just
All right. Breakout rooms are
and then
open.
we'll come back in 7.
Okay. Got it.
Thanks. Okay. So we had some fun. I don't need to share this right now. I would just like um a few enterprising people. We don't even need to hear from every single group, because I think we might have had more. But just in a minute or two, please come off mute and tell us what you talked about. Obviously, that was meant to be a semi-structured prompt for a conversation. If you ended up somewhere else, that's okay. So let's just hear from it and go ahead and popcorn it to each other. I won't bother calling on folks.
I can start with one thing that we talked about in group 2, which was just uh, that it's challenging to think of um, how to teach students at different levels, that what
Mhm.
first year students might need
Yep.
or be able to handle in terms of how you present the data or what you're asking them to do with the data could be very different from what you're hoping to accomplish with upper level students in a senior seminar, for example.
Mhm.
And Karen, did you want to bring in a point?
We also discussed Catherine's item in the chat, and I seconded it there, which quickly, it basically is what about box and whisker plots and 16 panel figures for upper level or complicated data, when the goal is for students to be able to process that data. And honestly, I think about teaching them to process visual data as a thing that's a goal in the class.
Mhm. So this is a common one that comes up, and I'm gonna go ahead and address it right now. It's its own talk. But I will come back with one response, and it's going to sound harsher than it's meant. Visualization, as the way we think about data, is ableist. You are knocking out an entire group of the population if we assume, as a community of scientists and educators, that the only way to represent a given type of data is visually. We've done something wrong at that point. But sometimes we're going to have to work around that. And that's okay. The 16 panel figure, I think that there are a lot of folks who would argue that that is a terrible figure for
Yes.
everyone, right? So some of this, and this is a key point that I want you to take away, and I bet a lot of your conversations pulled this out. What I'm talking about here and what other people who talk about this stuff are getting at and want to get across is this isn't just a technical challenge. This is a social challenge.
Yeah.
We have to talk about openly as a community what our learning goals should be. Is your goal, and I mean, this is a toy thing, is your goal that I can interpret all the things on a PCA plot? Or is your goal that I can interpret the results of a PCA analysis? Those are two very different things, right?
I love rephrasing it as interpreting the data and the results and the data. And
Right.
that is on the list now of things I could do differently and that are easy. Like
Yeah.
the social change, that one's
That's a hard one.
but we could
Right.
start with not saying visualize. And we struggled with that in our small group as well. But interpret data is both less ableist and more accurate for what I want.
Right. And there may be a million different ways that we can represent that data. We may get to a point where I can talk to the data and I don't need to smoosh it into 2 dimensions when it's got 372, right? Yeah, there's a lot to unpack there, and I'm really glad you brought it up because sometimes we get pretty locked in and it's tough. And I know that we're down to about 2 minutes and some folks have to take off, but does anybody else want to bring something in from theirs? And then I'll end very quickly with some of the ones that I think are kind of easy.
I mentioned in our group that basically there is a lack of consistency across how data is collected, and that lack of consistency sucks and it makes it really impossible to actually use this data. So that is something that we can teach, right? We can standardize how we collect certain data and keep it all in one same format. So eventually, if you're in the University of Oregon and versus North Carolina State, that data can still merge and we can use it in different universities.
Right. Yeah, being honest about the challenges is a good thing too. And that actually touches on something that came up in my group, and the gentleman, I'm sorry, I didn't get to see your name, was almost apologetic about it and shouldn't be. File naming conventions and teaching that as a concept that you need to be careful with, that they need to be meaningful, that you can't, and this is where I can go into some very easy, like low things that I think are low-hanging fruit. You cannot have V1, V2, V3, V4 as the columns in your spreadsheet. Those variable names are meaningless. And getting folks in the habit of doing that, have them write README files. I've done that. I've had students write me README files to describe their data, what the variables mean. That's a data dictionary in the FAIR language. Describe the instrument that collected it. Give me a metadata file, and gave them a schema. There's something called Dublin Core, which is very basic, and you can put about any data type into it and write metadata for it. So those are things to explore that a lot of those may sound like good scientific best practice. And sure, that's just some of it is. But casting it in and being transparent with students about casting it in, this is also about how like data works and data ecosystems work, and also making sure that everybody in the class can read it. So I'll stop there. I can stick around and answer questions if people have them, but I want to respect everyone's time. And thank you so much for participating and engaging. I love working with groups like this that aren't pulling teeth. You all are awesome.